Good day, students. Welcome to math.serve.com. In this installment, we're going to be going over part 6 of the ELM review questions for algebra. We'll be doing problems 71 to 75. Do visit our site at math.serve.com for a wide collection of math tutorials ranging from algebra to calculus. All right, let's take a look at problem 71. We're solving an algebraic equation involving radicals. So let's go ahead and write it down. It says if the square root of x minus 1 is equal to 4, then x is. So we're basically solving this equation. Now, there are two ways that you can solve this problem. You can solve it algebraically, or you can just plug in possible results and solve. Okay, so let me solve it algebraically first. Let's call this method 1. Method 1 is using algebra. Okay, all right, so let's go ahead and do that. So the inverse of square root is square, so we have to square both sides. Square the left side, square the right side, and that yields x minus 1 equals 16. And then you add 1 to both sides of the equation, and then you have x equals 17, and the answer is option D. All right, so for method 2, let's plug and check, plug in. The thing about this method is depends on where the answer is. That could determine how long it's going to take you. So let's say the answer is option E. That means you have to check A, B, C, D, E, and whichever one works, that's your answer. Okay, and you also have to be proficient at carrying out your order of operations and also in your arithmetic in order for this to work. Okay, personally, I prefer solving it algebraically because you just deal with that one problem and you're done. Let's try method 2. We're going to test option A, which is x equals 3. So we have to plug it into the problem. The question is the square root of 3 minus 1 equals 4? Is it? Square root of 2 is square root of 2 equals 4. The answer is no. So that means option A is not the answer. Then you go to B. You want to test x equals 9 to see if it's just a solution. So the question is the square root of 9 minus 1 equals 4? All right, and you simplify this. Is the square root of 8 equals 4? If you simplify this, this is 4 times 2, which is 2 root 2. Is that equal to 4? The answer is no. You see how long it's taken? If the answer were option A, this would be very fast. You know, just plug it in and then you're done. But you see how long this process is taking because our answer is not option letter A. Okay, so let's go ahead and test C. C is x equals 15. So the question is the square root of 15 minus 1 equals 4? If you work this out, is the square root of 14 equals 4? The answer is no, so option C is not the answer. And then you try option D, x equals 17. This should work because that's what we got in using method 1, the algebraic process. So if you plug that in, you have to ask yourself, the question is the square root of 17 minus 1 equals 4. And then if you do the arithmetic, 17 minus 1 is 16. Is the square root of 16 equal 4? Square root of 16 is 4. Is 4 equal 4? Yes, so that works out, and we can see for certainty that our answer is number 17. Okay, so plugging and checking is a shortcut for equations that you do not know how to solve. So you just take advantage of the fact that this is a multiple choice problem, so you just plug in and solve it. All right, let's move on to question number 72. It says an apple falling from a tree is 8 feet above the ground t seconds after it begins to fall, where h is equal to 64 minus t squared. After how many seconds will the apple hit the ground? So when does the apple hit the ground? So how far, let's say this is the apple, and this is the ground, and let's say this is the initial height, h initial, which is basically 64 if you look at the equation. So this is the initial height, right? This is the initial height. So when it's on the ground, how high is it from the ground if it's on the ground? It's 0 feet from the ground. Okay? So whenever you're asking for when it hits the ground, all you're asking to do is solve the equation when h of t is equal to 0. Okay? So the apple hits the ground, hits the ground when h equals 0. Alright, so all we do is basically rewrite the original equation. So the equation we have is h equals 64 minus 16t squared. So we're to solve this equation for 8 when h is equal to 0. Okay, so just set h to 0 and solve. So if we do that, we're going to have 64 minus 16t squared is equal to 0. All right, let's go ahead and solve that. Subtract 64 from both sides. Subtract 64. And then we have negative 16t squared is equal to negative 64. Then we divide both sides by negative 16. And then we have t squared is equal to positive 4. And then you take the square root of both sides. And then you have t is equal to plus or minus 2. Now, since time is always positive, it can only be positive, t is going to be equal to 2. The negative time makes no sense. So t is equal to 2, t is equal to 2 seconds. So what does this result mean? It means that the ball hits the ground after 2 seconds. So our answer to number 72 is option letter B. Alright, let's take a look at problem 73. It says a golf ball is hit so that when it is directly above a point that is x feet from the golfer, it is h of x equals 30x minus 1 over 10x squared feet above the ground. How far from the golfer will the ball hit the ground? Alright, so this is another problem that's very similar to the previous problem. This is known as a free-fall equation problem. It's an application of quadratics, okay? So what's similar between this problem and the previous problem? Hitting the ground, the ball hitting the ground, okay? So that's what we have here. But the difference is that the other one was calculating time, but this one is calculating distance, okay? The distance between the ball and the golfer. So it says how far from the golfer will the ball hit the ground. So, but the similarity here is that when the ball is on the ground, how high is it from the ground? We already talked about that earlier. When the ball is on the ground, it is 0 feet above the ground, okay? So let's write that remark again. The ball hits the ground when h is equal to 0. Alright, so let's go ahead and do the calculation. There, we're just going to plug in 0 for h and solve for x. So we have 30x minus 1 over 10x squared equals 0. Okay, so you just replace this h with 0. Let's go ahead and solve that. Let's see if I can pull out a greatest common factor. X is common to both terms, so I can pull out an x. So we have x times 30 minus 1 over 10x equals 0. And then we're going to use the 0 product property. Here we have x equals 0 and 30 minus 1 over 10x equals 0. This is already solved, but what does this mean? It means that initially the ball was 0 feet away from the golfer when it was on the ground. That's before it hit it. And also another distance in the future, that's when the ball hits the ground again. So what is that distance? That's what we want to solve for. Okay, so let's go ahead and focus on this equation. This is of no consequence here. Let's solve this. So how do we go about solving this equation? it's a two-step algebraic process. We'll get rid of 30 first, and then we'll get rid of negative 1 over 10. All right, let's do with the 30 first. You add 30. Actually, we have to do the opposite, right? So we have to subtract 30 from both sides. Subtract 30, subtract 30. And then we have negative 1 over 10x equals negative 30. Now to isolate x, we simply multiply both sides by the inverse of negative 1 over 10. Another word for inverse is a negative reciprocal. Okay, so let's multiply both sides by the inverse of negative 1 over 10. Actually, just multiply both sides by the reciprocal, not the inverse. I'm sorry. So multiply both sides by the reciprocal. So we have negative 10 over 1, and then negative 10 over 1. If we multiply by the inverse, which is 10 over 1, the negativity will still remain, and that's a problem. We want to resolve this fraction and also the sign simultaneously. So multiply both sides by the reciprocal. So multiplying both sides by the reciprocal is the same thing as dividing both sides by the number, the coefficient, which is negative 1 over 10. Okay? So divide the 10, they'll both divide into 1. Minus times a minus is plus, and then you have x equals negative 30 times negative 10. Remember, minus times minus is positive. 30 times 10 is 300. Okay, feet. So this is how far the ball was from the golfer when it hit the ground. Okay, so our answer is option letter E. All right, let's move on to problem 24. This is assessing our ability to solve and graph linear inequalities. Okay, so if you take a look at this linear inequality, absolute value inequalities. Okay, so it's also an absolute value inequality. So if you want to solve this absolute value inequality, one thing you want to note is that the orientation or the form of the absolute value inequality can help you make an educated guess as to what this correct solution is. So if you look at this setup right here, you have the absolute value of a quantity less than or equal to. Anytime you have less than or equal to, your solution is going to be a bounded region. Okay, what does a bounded region mean? It basically means that your solution set is going to reside between two finite x values. Okay, you don't go to infinity in that situation. So this is what a bounded region looks like. You do not exceed two finite x values. So if you take a look at, with that in mind, just take a look at all the options you have. Since you have less than or equal to, which implies your solution is bounded, you can automatically eliminate the unbounded options. So the unbounded options are options B. Well, actually, option B is bounded. We can eliminate option C and option E. So our answers are either going to be A, B, or D. Now let's go ahead and solve the inequality. So we have the absolute value of x minus 2 plus less than or equal to 3. Now, since this is a bounded inequality, we can retain the sandwiched format for the entire problem-solving process. What does that mean? This absolute value means that this quantity is between this number and its opposite, which is negative 3. So I can rewrite this as negative 3 is less than or equal to x minus 2, which is less than or equal to 3. So this reflects the true bounded nature of this absolute value inequality. Now, if it's greater than, you must solve them separately since your solution is not a bounded region. The goal here to solve this combined inequality, 2-in-1, is to isolate x in the center. To get x isolated in the center, it's a one-step algebraic process. You simply add 2 to 3 sides of this equation. You add 2 to the middle, to the left, and to the right. If you do that, you're going to end up with negative 3 plus 2 is negative 1, less than or equal to, this cancels out, x less than or equal to 5. So x is between negative 1 and 5, and we can clearly see that our answer is option letter A. Okay, so let me just graph it for you just to show you how to graph linear inequalities. This is a composite or combined linear inequality. So to graph this, we have negative, let's say this is 0, this is -1, and then 1, 2, 3, 4, 5. So since you have a line on the inequalities, it means that the endpoints are included in the solution region. All right? Since you're between, your solution is going to be every point on -1 and 5 and between, down. So there goes your answer, option letter A. All right, let's take a look at number 75. It says, what are values of x for which the absolute value of 2x minus 3 is equal to 5? This is an absolute value equation. It's 2 points, unlike number 75, which is 74, which is an absolute value inequality, which represents a region. Okay, so you want to keep the difference in mind. In this case, we're solving for boundary points. Where are the boundary points here? Okay, so to do that, let's get rid of this absolute value. Absolute value is distance from 0 to the left or right. To the right is positive, to the left is negative. So replace absolute value of 2x minus 3 with plus or minus 2x minus 3 equals 5. We need to move this plus or minus to the other side, so we can just simply divide both sides by plus or minus 1. Plus or minus 1. So we have the quantity, we just have 2x minus 3 equals plus or minus 5. Now, we have two equations in one here, so to solve it, for our two answers, we must solve the combined equation separately. All right, so let's do the negative piece on the right. 2x minus 3 equals -5. And then let's do the positive piece on the right. 2x minus 3 equals +5. So we're going to have two answers in this situation, okay? All right, so let's go ahead and solve this. This is a two-step algebraic process. We're going to add 3 to both sides and divide by 2, okay? So add 3. That gives us 2x equals -2. Remember, when you're combining numbers and the signs are different, you subtract and keep the sign of the bigger, okay? Divide both sides by 2. And then you have x equals -1. That's your lower boundary point. And then the other one, you solve this. This is also a two-step algebraic process. Get rid of the 3 and then the 2, okay? So we add 3 to both sides. 2x equals 8. And then divide both sides by 2. X equals 4. So our solutions are x equals -1 and x equals 4. These are the boundary points for this absolute value equation. So we can clearly see that our answer is option letter C. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel for updates to the remainder of this ELM review series. And do feel free to post a comment to let us know what you think about this clip. We appreciate it. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.